Good morning, everyone, and welcome. I'm excited to be here today to talk about WAN concepts. Today's presentation is part of my course project for IT 6300. My name is Jedediah Ashenza. On this first slide, we're setting the stage for what's to come. I'll give you a quick overview of the key topics we'll cover related to wide area networks. So, let's get started and explore the fundamentals of WANs together. Let's talk about wide area networks, or WANs for short. These networks are what connect local area networks, or LANs, across large geographical areas. Think of them as the bridges that link different branches of a company, data centers, or even remote employees working from home. Without WANs, these distant locations wouldn't be able to communicate seamlessly. They truly serve as the backbone of global networking, enabling the flow of information across continents and oceans. Understanding WANs is essential because they form the foundation of how our interconnected world operates today. Let's take a closer look at WAN concepts. First, WAN topologies, which are the different ways networks can be interconnected over a wide area. We have point-to-point, which is a direct connection between two sites. Then there's hub and spoke, where multiple remote sites connect to a central hub, making management easier. And full mesh, where every site connects directly to every other site, providing high redundancy and reliability. Next, let's talk about WAN devices. Routers are essential. They direct traffic between networks. Switches can also be involved, especially in more complex setups. Modems are used to connect to internet service providers, translating signals for digital communication. CSU-DSUs are specialized devices that connect digital circuits over leased lines, ensuring data is transmitted correctly. Moving on to WAN protocols, which define how data is formatted and transmitted. Frame relay, for example, is a packet-switched protocol used for connecting local networks over wide areas. MPLS offers efficient data routing and is great for VPNs and traffic management. PPP, or point-to-point protocol, is used for establishing direct connections over serial links. And VPNs, or virtual private networks, enable secure connections over the public internet, extending your private network. Finally, regarding WAN services, there are various options available depending on needs. Leased lines provide dedicated, private connections, ideal for high security and performance. Broadband offers high-speed internet access suitable for many applications. Cellular services provide wireless connectivity, which is especially useful for remote locations or mobile users. By understanding these concepts, topologies, devices, protocols, and services, you can better design and manage WANs that support your organization's connectivity needs. Now, let's walk through the sample packet tracer configuration. First, we'll configure IP addresses on the router interfaces. This step is essential because it allows the router to communicate with other devices on the network. Next, we'll set up static routes for remote networks. Static routes tell the router how to reach networks that are not directly connected, ensuring proper data flow across different segments. Then, we'll assign IP addresses and default gateways to the PCs, which enables them to access the network and beyond. Finally, we'll test the connectivity using the ping command. This helps us verify that all devices are properly configured and can communicate with each other. Remember, these steps are fundamental to establishing a reliable and functional network. Let's take a closer look at some example commands for configuring our routers. Starting with router 1, we set up the interface as 000 by assigning it the IP address 10.0.0.1 with a subnet mask of 255.255.255.252. This step is crucial because it establishes the router's identity on that specific segment of the network. Then, we issue the no shutdown command to activate the interface. Without this, the interface would remain administratively down and communication wouldn't occur. Next, we add a static route on router 1, directing traffic destined for the 192.168.2.0 network to go through the IP address 10.0.0.2. This tells router 1 how to reach that particular network, which is essential for proper routing. Switching over to router 2, we follow a similar process. We configure its S000 interface with the IP address 10.0.0.2 and the same subnet mask, ensuring both routers are on the same point-to-point link. Again, we activate the interface with no shutdown. Finally, we set up a static route on router 2 for the 192.168.10 network, directing it through 10.0.0.1. This setup creates a clear, explicit path for traffic between these two networks, which is fundamental when establishing stable and predictable communication between routers. Overall, these commands highlight how manual configuration of interfaces and static routes forms the backbone of network connectivity, especially in smaller or more controlled environments. Let's wrap up with some key takeaways. WANs, or wide area networks, are essential because they connect different geographically separated networks, allowing them to communicate effectively over long distances. Think of them as the highways that link cities together. Routers, switches, and protocols play a crucial role here. They work together to ensure that these connections are reliable and secure, making sure data gets where it needs to go without issues. And of course, tools like Packet Tracer are invaluable for students. They provide a safe environment to practice configuring WANs, so you can build your skills before working on real-world networks. Altogether, understanding how WANs operate and being able to configure them is a vital part of mastering networking concepts. Let's take a moment to acknowledge the key references that have supported this presentation. First, we have the Cisco Networking Academy's Introduction to Networks from 2021, which provides a solid foundation in networking concepts and practical skills. Then, there's W. Odom's CCNA 200-301 Official Cert Guide from 2020, a comprehensive resource for understanding the certification exam and core networking principles. Lastly, Forozin's Data Communications and Networking from 2017 offers an in-depth look at the technical aspects of data transmission and network design. These sources are essential because they underpin the concepts we've discussed today, tying everything back to industry standard knowledge and best practices. Remember, mastering these references can really help deepen your understanding and prepare you for real-world networking challenges.